Students, this is Unit 5, Right Triangles, Lesson 5.5, Applications. Make sure you get a parent or guardian sign-off. We're going to recap the two concepts. Like this one, you are going to solve for x using standard SOHCAHTOA. This one, you're going to solve for theta using inverse SOHCAHTOA. Do these two on your own, restart the video to check. All right, let's see how you did here. So for this one, we have the hypo, and we want the adjacent. So that's AH, so that's going to be this one right here, cosine. Cosine theta over 1 equals adjacent over hypo. And so that's cosine 41 degrees. Adjacent, which is 20, over hypo, which is x. Cross multiply. We end up with cosine 41 times x equals 20. Therefore, x is ultimately going to equal 20 divided by the cosine of 41 degrees. My calculator here. That's 20 divided by 41 cosine. You should have gotten 26.500. So x equals 26.500, which makes sense because if that's the hypo, it has to be longer than 20. This one down here, solve for all the angles. We have our opposite, we have our adjacent, we have our hypo. You could use any one of these. I'm just going to go ahead and use sine. So inverse sine. Opposite over hypo equals theta. My opposite is 51. My hypo is 85. And I'm going to round to the nearest whole degree, so that's going to be 37 degrees. Take that away from 90 because this is 90. And this should be 53 degrees. All right, students, that's SOHCAHTOA and inverse SOHCAHTOA. Now you have all the tools you need to solve practical application problems. You need a calculator. I recommend a straight edge, a highlighter, and some colors. Keywords. We're going to learn today angle of elevation, angle of depression, and we're using trig ratios. Let's recap angle of elevation and depression. Angle of elevation starts at a horizontal and goes upward. Angle of depression starts at a horizontal and goes downward. Key thought is both angle of elevation and depression start at horizontals, which means the vast majority of the time your angle of depression and elevation will be armpits of the Z. This would be your depression, this would be elevation. So on this slide, I'd like you to quickly sweep the angle of elevation and depression for each of these and label them. For example, angle of depression is horizontal going down. That would be depression. Angle of elevation is horizontal going up. I'm going to pause about 20 seconds. You label the next two. All right, let's check to see if you got these two. Depression, horizontal going down, that would be your angle of depression. And angle of elevation, horizontal going up, that would be your angle of elevation. For this one, your angle of elevation is easy, horizontal going up, that's elevate. Your angle of depression, you had to add the horizontal going downwards. There's your angle of depression. Remember, your angle of depression and elevation make alternate interior angles. Pause the video, do this page, and then restart. All right, restart. Your angle of elevation is right here. That's E for elevation. Depression, horizontal going down, depression. Check this one. Angle of elevation, horizontal going up, elevation. Depression, you must draw in the horizontal going down. That's your angle of depression. This one, your angle of elevation, horizontal going up, elevation. Horizontal going down is your angle of depression. Super important that you're able to spot these, especially your angle of depression, which is usually a little bit harder to draw. We're going to do 3 practical application problems. It is super important you learn to follow my directions. We're going to do 3 together and the 4th one on your own. Okay. Step 1. You're going to read with your finger on the paper. So you notice the little finger there? I want you to physically put your finger on the paper as well. Ready? Read out loud with me. An airplane is flying at 5,000 meters altitude. The plane is 72,000 meters diagonally from the end of the landing strip. At that moment, what is the angle of descent or depression of the airplane coming in for a landing? Step 2, we're going to highlight all our numbers and keywords. So underline these with me. 5,000 meters altitude, 72,000 meters distance diagonally from the end of the landing strip. It is asking us what the angle of descent or depression will be for the plane coming in for a landing. Whenever you have real-life problems, it's important to establish where ground is. Now we're going to draw, label, list, cross it out as you do this, then we'll do have, need, do. So I have an airplane. It's coming in for a landing, so I'm just going to kind of draw my landing strip here. So I'm going to draw a line that represents the airplane coming in for a landing. I cross out the word airplane. It is 5,000 meters in altitude. Altitude, by definition, always creates a right angle. The word height and altitude always creates a right angle. This is 5,000 meters. The plane is 72,000 meters diagonally. Diagonally means diagonal. From the end of the landing strip. At that moment, where is the angle of descent or depression? Super important. Angle of depression starts at a horizontal and goes downward. So this right here, the yellow, where most students actually identify, that is not the angle of depression. Your angle of depression here is horizontal going downward. That, my friends, is the angle of depression, and that's going to be our theta angle that we're looking for. So we're going to close this up. Notice we make a rectangle. Once you've accounted for everything, including what you're trying to find, now we do have, need, do. And we have the opposite and the hypo. We need the theta. So have opposite and hypo. Need your angle theta. So this is where you do, OH is so, but it's inverse cosine because you're looking for the angle. Or inverse sine, excuse me, inverse sine, opposite over hypo is going to give you that angle theta. So it's going to be inverse sine. Your opposite here is 5,000. Your hypo is 72,000. I'm going to pause 20 seconds here. You get your own calculator, calculate that theta, and then match it with mine. I'm going to pause 20 seconds. Let's see how you did. So we're going to go 5,000 divided by 72,000. Second function, sine. I'm going to round, that's 3.98 degrees. So it is approximately, our angle of descent is 4 degrees. So look at the steps. Finger track, read out loud. Highlight, underline, draw label list, have, need, do. I'm going to give you a quick heads up here, friends, on the test that you're going to take for this unit. The test, if this was a problem on a test, let's say a 10-point test. This whole thing was 10 points. Let me show you how I'm counting the points. The points are not 10 points just for the answer. The answer itself may be worth 6 points. But then the work, all the work and the diagram may be worth 3 points. That's only 9 points. What else am I going to count? Students, if I don't see you highlight and underline keywords and numbers and cross it out, you're actually going to lose points on a test, because on this next test, just doing this filtering step alone is going to be 1 to 2 points each problem. Which means if all you do is go straight to your calculator, crunch out a bunch of numbers, bam, bam, you only got 6 out of 10 points, folks. You have to be able to draw accurate diagrams and show me that filter step. Let's do 2 more problems together. Finger on paper. A research vessel uses sonar to find an unknown object on the seafloor 1,000 feet diagonal distance from the hull of the ship. The angle of depression from the hull of the ship to the mystery object is 27 degrees. How deep, straight down, is the object? Ready? Go back, underline all your numbers and keywords. We have a research vessel and an unknown object. 1,000 feet diagonal from the hull of the ship. We have an angle of depression, 27 degrees. How deep, straight down, is the object? So we just did our finger underline. Now we're going to draw a label list. So in this storyline, we have ocean and we have ocean floor. We have a research vessel of some sort. And we have an unknown object that is 1,000 feet diagonally from the hull of the ship. Notice I'm crossing stuff out as I account for it. The angle of depression From the hull of the ship down towards the mystery object, horizontal going down is 27 degrees. Question is, how deep is the mystery object? There is your X. Have, need, do. We have the hypo. We need the opposite. Notice this time we're doing a side length. So we're using standard SOHCAHTOA. I have an OH combo, which goes with SO. Sine of theta over 1 equals opposite over hypotenuse. Circle, plug, chug. Sine of theta, 27 degrees. Notice I'm physically picking it up. Our opposite is X. Don't touch a calculator until your variable is by itself. Ready? We're going to cross multiply. Keep parentheses around that. X is by itself. Now you can grab your calculators. Double check your work with mine. We're going to round to the second decimal place. Our X here, which is the depth of our mystery object, is 453, check your units, feet, 0.99. Let's try one more problem together, and then you're going to do one problem on your own. Get your fingers on the paper, please, and read with your lips moving. Tom is standing 400 feet away from a tree. He uses a clinometer to measure an angle of elevation from his eye level to the top of the tree to be 38 degrees. Tom is 5 feet 4 inches tall. His eye level is 5 feet above the ground. How tall is the tree? Go back, underline, or highlight all your numbers. Tom is 400 away from a tree. He's using an instrument called a clinometer, which I'll explain in a moment, to measure the angle of elevation from his eye level to the top of the tree, 38 degrees. Tom is 5 feet 4 inches tall. His eye level is 5 feet above the ground. And our question is, how tall is the tree? A clinometer is a device that measures angles of elevation. A physical clinometer might be something that has a viewing piece with a plumb line and like a protractor-like thing, and when you tilt it, that string is going to hang at an angle. You can also use an electronic coulometer. So coulometer, when you see the word coulometer, it measures the theta of elevation or depression. Storyline. Establish ground. We have ground here. We have Tom. Tom is standing 400 feet away from a tree. So he's standing 400 feet distance. There is always going to be horizontal, 400 feet, check units, away from a tree. Okay, so we have a tree of sorts. Okay? He takes the clinometer that he holds at his eye level. Okay, so this device is handheld. It's being held at his eye level. And from his eye level, he measures the angle of elevation to be 38 degrees. Now watch very carefully. An angle of elevation always starts at a horizontal and goes up. So if he's measuring from his eyes, you have to draw in this imaginary horizontal line, because the angle of elevation is being measured from a horizontal going up from his eyes, and that is 38 degrees. You can bring that 400 is also from here to here. Tom is 5 feet 4 inches tall, so from the top of his head down to his feet, he's 5 feet 4 inches, which is 5 4/12, which is 5 1/3, which is 5.33. So he is 5.33 feet tall. But watch out. The measurement is specifically taken from eye level. So this right here is 5 feet. Our goal is to find how tall is the tree. So I'd like you to do this bracket. Height always comes from top all the way down to the ground. So put a little bracket there. That is our ultimate X. In fact, let's just make that a question mark. That's our ultimate question, if you will. This actually takes 2 steps. If you notice, your right triangle that you're actually going to work with is this highlighted triangle right there. You might want to shade it or stripe it. We're going to come in for a little bit closer shade, which means we've got 2 parts to this. Drop that down. There's your right angle there, folks. So from the 38, this is our opposite. This is our adjacent. There is our hypo. Have, need, do. We have the adjacent side, which is the 400. We need the opposite, but warning, opposite is only that squiggle. We do need it. It's going to come into play here, but we need the opposite. What do? We have an OA combo. Tangent, TOA. So it's tan of theta over 1 equals opposite over adjacent. Circle, plug, chug. Tan of your theta is going to be 38 degrees over 1 equals our opposite, which we don't know, over our adjacent, which is 400. Cross multiply. Our opposite side there is going to equal, very simply, tan of 38 times 400. Your unknown is by itself. Let's do our math here. You want to follow along, write this down. 38 tan times 400. Take it to the second decimal place. So we just found that opposite red side is 312 feet, 0.51, 312.51. But wait, there's more. The actual height of the tree, I'd like you to put your fingers physically right there. Slowly trace with me going down. Trace with me going down, 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 down. That's the whole height of the tree. Ready? I'd like you to trace with me again, starting from here. Watch. From here to there is 312 feet, 0.51. That's not the whole thing. Obviously not done to scale. The measurement is taken 5 feet off the ground. So now trace that 5 feet over here, trace it over here, trace it over here again. Notice that our complete unknown is going to be 312.51 plus we have to add, because we took our measurement, 5 feet off the ground. So the total height of the tree is 517.51 feet. I would like you, this had a little bit of a trick to it. I'd like you, in the margin, put a little star, and write yourself a note. What was something that made this problem a little tricky? Put it in the margin. I'm going to be looking for that. What did you have to watch out for? This last page, you're going to do completely, wholly on your own. Draw, label, list, cross out. Have me do. Restart the video when you're done. Pause. All right, welcome back. You have a plane taking off, elevation 14 degrees, altitude of 20,000 feet, diagonal distance, what is it? Our plane takes off at an elevation of 14 degrees. And it reaches an altitude of 2,000 feet, maintaining that degree. It's asking, what is the diagonal distance? There's your x. Have, need, do. Sine of theta over 1 equals opposite over hypo. Sine of 14 degrees over 1 equals our opposite, which is 2,000, over our hypo, which is our unknown. So our diagonal is going to be 2,000 divided by the sine of 14. You don't touch a calculator until your x is by itself. We have 8,267 feet, 0.13. Double check your work. If you've done that correctly, smiley. If not, write yourself a note as to what happened.